made Minecraft for the Gameboy Advance, and this version is finally playable. I fixed all the problems and I am finally going to release this version. Okay, let's get into this. That was actually pretty hard going out here to film the intro. I don't know why I'm doing this, but please subscribe. But why would I do something like this? Well, I went a little bit over it in the last video, but the short version is I'm a little bit crazy and irresponsible and I like to do impossible things. And a version like this doesn't exist on the GBA. There's another version by 3D Sarge that I also talked about and it's very amazing. But what I really wanted was having a version where you're getting this feeling of being dropped in a world that you can explore. And this is where I can show you Minicraft 3D. In this game you have a menu where you can choose between a super flat world and a classic generated world, where you can even put in your own seed or use a random seed. To make everything simpler for now, I decided to only use GBA buttons for the seed. But I mean, it still works. You can get a seed and share it with other people. And then you can explore a world that is automatically generated. You can destroy blocks and you can build blocks. There's a sprint feature, a jumping feature, and everything can be controlled on the GBA, including looking around, looking up and down. And I also created a block bar for the blocks that are available right now. And also there are a lot of graphical settings. You can easily adjust the render distance, make the game run much faster when you want to walk around with a lower render distance, and if you want to look at buildings, it's very nice to just increase the render distance for that. You can also increase the FOV and you can even adjust the sensibility, how many blocks are rendered in your view. The normal render distance is a little bit higher than what I usually walk around with, so I often decrease the render distance when you walk around, but I still decided to keep it a bit higher because it's a nice balance between frames per second and also what you can see. This is a very basic version. And even though I already added quite a few features, it's still noticeable that a lot of things are not included in this. The main purpose of this version is to get a feeling of what is possible on the Game Boy Advance. And for a few things it is already quite functional. But I am planning to add a lot of features to this version. I might even be able to add a survival mode. Proper textures is also very important, even though I quite like the look I have right now, but it is very basic. And I will also work on increasing the performance even further, because I think there are still a lot of things that can be done. And I want the game to be playable with a higher render distance. And also hopefully make the world size a little bit bigger. Because at the moment I'm loading the entire world into the RAM of the GBA, and that's a bit of a problem. One of the big things I need to figure out is making the world load dynamically into the RAM, which should definitely be possible, but it will require a lot of work and there are many other things I had to fix first. So you can expect a lot of updates in the future. But why is this so difficult on the GBA? Well, the GBA is basically a little bit of an in-between console. So on the original Game Boy it was almost impossible to do 3D rendering, and on the Nintendo DS it is very easily done. So the GBA really is this weird middle ground where some 3D rendering is possible, but you can really only use software rendering on the GBA. And I like to compare this to trying to run a high graphics game on your PC without a graphics card. And that's very difficult. But that's what we have to figure out on the GBA. Also, we don't have a C buffer, so we have to use Painter's algorithm, but this is already like much more advanced. The point is, there are a lot of tricks and optimizations you need to do, but it is somehow possible, and this makes it so interesting. We've also seen this with other projects that I found very inspiring. I also went through this entire beginning journey in the other video, so you should look there for more details. But basically, I first made a prototype in JavaScript and then tried to get all these ideas working on GBA, and yeah. I had a lot of problems at the beginning, and I was so happy when I got the first working version. But now I'm so much further because this new version is running fast enough that you can play it. But to make this version ready for a release, there were two main bottlenecks I had to fix. You saw these bottlenecks the last time I showed this game, and those were the performance and how often the game crashes. Basically, I had a problem that the game would always crash after playing it for a while, and at the beginning when the performance was so bad it was not so noticeable, but I still noticed it quite a bit. And I noticed that that happened very often when I was spamming different controls at the same time. So I built a lot of safeguards into the code. I also added a lot of logs so I can easily diagnose the problems, but the logs didn't help at all. I had to do a lot of manual things, and also the game sometimes still crashes on the emulator, but that's an emulator problem because the same crashes don't happen on real GBA hardware. But after a long time, and I really mean a long time, I managed to get the game run properly without crashing all the time. It can still happen, but it's very rare. And please keep in mind, this is optimized to run on real GBA hardware. But now let's talk about the performance and how I managed to actually improve the performance of this. Because in the last version the game was running with 1 frame per second and it was completely unplayable unless you're the most patient person in the world. So I kept doing research, and to be honest, the solution was so much easier than I thought. Because actually I was thinking about using assembly or some other things, but it turned out that my renderer approach was just wrong. Basically, I used the raycaster to render each pixel separately on the GBA. And the problem was that I basically did a loop that went over every pixel and decided how it should look like. And the thing is, this is something that really can work on better hardware without any problem. But the GBA is just too slow for all of this. And the solution was simple. So I just had to change the entire renderer to a face-based polygon rasterizer. Yeah, it can be less accurate than a raycaster, but it gets the job done. I did a lot of prototypes to implement it, and then I started implementing it into the real code. Basically now I changed the renderer so the faces of the blocks would be rendered directly, which is much easier for the GBA to do. So I created 2 triangles that would together create the face of a block. And if you do the math, each block is made out of 6 faces. So the important thing was to only render the faces you could really see. And this implementation is not so simple. I mean, the prototype I showed at the end of the last video still had a lot of bugs, but I kept working on this and the entire thing just worked better and better. This entire project is still written in C. Yeah, I managed to avoid using assembly even though I actually tried at one point and it didn't work at all, but that's a different story and I don't want to bring back any trauma. And I don't want to get too technical in this video, but I want to show you one of the most important functions in the renderer. I will try to make this fun, okay? Basically, this is a function in C that decides whether a face is rendered or not. So remember, each block is made out of 6 faces and we need to see if the camera should actually render it or not. Basically, we have a static function, which is just a private function. Only this file can use this function, but anyway, we have a special IVRAM code, which basically is a tag for the compiler that we use the Gameboy Advance fast memory. A void function just means that the function doesn't return any value. We have the input parameters that we need for the function to know the position of the block in the world. And then also as an input, we have a pointer to a vector which represents which way the camera is looking. Wait, a pointer? Okay, everyone calm down. A pointer is not so bad. It's actually very simple and straightforward. Unless you're ChatGPT. Yeah, ChatGPT in C code, good luck making that connection work. Anyway, it's much easier to just address the camera position like this. And then in the function, we basically just set the visibility to false, and then we check with the switch statement whether the side we are checking is actually facing air or the outside of the map. Because if this is not happening, we can already use the return statement to get out of the function. And then we keep going by checking if the face is actually facing the camera. Okay, I'm already doing this too detailed. But then we also need to check what the position of the face is and if we should even render it with the render distance or not. And then At the end we basically add the entire face to the render disk, to the face buffer, and this function is very important because it checks what should be rendered. And you have to imagine, this function can potentially be called a few thousand times per frame. So this function has to be super efficient. That's why it's so important to have the concept of early returns in the function, because there's no need to continue if a face is not visible. So yeah, these were just some of the basics, how everything is working technically. This entire project is very important for me and it feels amazing to be able to share it finally. I have a huge amount of things I want to add to this, and I'm very happy to hear suggestions what I should add and how I could do it. And to make this accessible for everyone, I have decided to post the entire source code that I made on GitHub. You can go there and compile the game for yourself and make it run on your own GBA. But for people that just want to instantly play the game as fast as possible, I am also offering the option to get the ROM directly on my Patreon. Projects like this take a lot of time and dedication, and to be able to keep doing something like this, I need your support. So if you want to see more updates of this in the future and similar projects to this, Patreon is a very good way to support me and motivate me to keep going. Every time I will post an update video, I will also post an updated version to the code and make it available. But while I'm working on this and before I make another video, I will also post some updated versions on my Patreon. Of course, anyone can also take the code and keep working on this and show me what they've done with it, and I would be very excited to see all of this. I'm very excited to see where this project is going in the future, and I think we have only scratched the surface of what is possible on the GBA. Thank you so much for watching, and if you enjoyed this video, then you should watch the video where I made Photoshop for the GBA.